Okay, so as we said, switches are bound to have loops because of the fact that they're able to do what we call learning. And so at every point in time, because of the ability to learn about, say, devices connected to it directly or indirectly, or because of the fact that it can also send broadcast messages about to seek for information, there's also going to be some kind of inconsistency and also a broadcast storm. But this is a big issue when it comes to devices in our local area networks, because switches, they work closely with the device, the end device, so like a PCs and all that. So normally you feel the effect directly when a loop happens within the network, because it's something that will affect you if you connected via switching, or even if it's wireless, there's a way that will affect it. But the answer is, or the solution to this problem will be spanning tree. And so spanning tree is that guy who will start asking. So let's just look at spanning tree like a language between switches, a language that they will say, hey, my brother, something like, hey, are you connected to me via a different link again? And if this guy says, yes, I am. How? I'm connected to you via this link. And so because of this idea, the two devices will be able to understand that there is a loop, and the mechanism or the language that will help them to understand that there is a loop is what we refer to as spanning tree. Because once they detect that there's a loop, they would block one link and say, okay, since we've agreed that there's two links, can we agree on which link to use and which one to use as our backup? And so they will agree to it, and then they'll block one link. And then now, because of what just happened, they've agreed to disagree. And so no, they're not going to use the second link again. Everybody is going to go via this link. And this link, the second link, is only going to be a backup if this link fails. Now, spanning tree will prevent loops by putting one side of the link to block it, because if it's blocked, then it means that there's no way information can travel from here to here. So this part of the link will send a signal to this guy saying that, hey, I'm not even working. Even if you want to send something to me, I cannot help you because I'm blocked. It's like a tunnel. There's no direction. So there's no way you can get closer to me. You cannot go through me, but you can go through this other link. And that's what spanning tree is doing. It's preventing the loop. So by blocking one port. So when it blocks the port, it forces all the traffic to go through one direction. And that's basically what we've done here. We're saying that if the second link, which is the alternate link, is blocked, then we'll all go through the first link. The blocking ports is always blocked because we want to prevent the loop. And so if for some reason this is not blocking again, then the loop would not be prevented and the loop will happen again. Because of spanning tree, since we block one link, everybody will be sending information via this link. And so, for example, this device, if this guy is connected, would say, I know about AA from F0/1. If this is, so let's say F0/3, I know about AA, which is on F0/3. This guy also say, I know about AA from F0/1. And so basically, since this guy doesn't know about AA because it's blocked, this guy cannot send the same information to this guy and say that, hey, I know about AA. No, it's only this guy that knows about AA. So there's some kind of consistency. And so there will be no broadcast storm. You cannot send even any message from here because this is blocked. And there will be no copies of the traffic. We call it a frame because it's a layer 2. There's no copy of the frame coming through another direction. And the database is stable because it's consistent because there's only one AA from one direction. That's it. And so you realize that spanning tree is solving that problem.